All right, so 5.6, this is 5.6, right? Foundations, Math 10, 5.6, number 20, right? So it says you can estimate, it's frozen. There we go. So you can estimate the distance in kilometers between you and a distant storm by measuring the time in seconds between seeing a lightning flash and hearing the thunder. So light travels much faster than the sound does. And so if you see a lightning flash, it travels almost instantaneously. It's not instantaneous, but it's very close to being instantaneously. As soon as it happens, you see it, even from a distance away. But the sound travels much slower. So you'll see a lightning flash, and then a little while later, you'll hear the thunder come across, the sky above you, and you'll be able to hear it. So it takes some time. You guys all know that. How do you figure this out? Well, the time in seconds between seeing a lightning flash and hearing the thunder, then dividing by 3. So you take the time and you divide it by 3. The time divided by 3. This works because sound travels at approximately 0.3 kilometers per second. So is this relation between distance and time linear? Justify your answer. So you could do two things. You could either graph this. Okay, you could find an equation. You could go straight to the equation and look at it and see if it's in y equals mx plus b form. It can be in that form. That's a straight line, so that's linear. You could make a table of values and see if the constant change in one variable matches a constant change in the other variable. Or you could graph it. You could graph the points and see if they form a straight line. So you have 3 different kind of options. I would probably tend to making a table of values and seeing if they jump at the same rate. So what are we dealing with here? We're dealing with distance and time, I guess. Estimate the distance in kilometers between you and a distant storm by measuring the time in seconds. So we measure the time in seconds, and then we do something to it to get the distance away, right? So the time is the independent variable, looks like, and the distance would be your responding variable or your dependent variable. So, okay, so what I'm going to do is I'm going to test some times, okay? And how I do that is I put the time, okay, so the time in seconds, and I divide it by 3, and that should get me the distance in kilometers. So here's your equation. The distance in kilometers is time divided by 3 seconds. Okay? So if I pick 0 seconds, does that even make sense? You might not want to put 0 seconds in there because does that even make sense? If there's 0 seconds between the lightning flash and the sound, that means that you just got struck by lightning and the distance between the lightning and the storm is like 0. Okay? So if you don't want to use that one, I understand. Let's say 1 second. Okay? So what we do is we put in 1 here in for t. And so this is going to be the distance in kilometers, so the distance is 1/3 of a kilometer. See that? You put 1 there. Okay? 2 is 2/3 of a kilometer. And 3 seconds is exactly 1 kilometer. So that's a good one to remember. If you see lightning, like 1,001, 1,002, boom! That lightning flash, that lightning struck 1 kilometer away, 3 seconds. Okay. I think when I was a kid, we didn't use kilometers so much. I mean, I was taught that I think about 5 seconds is 1 mile. So you count 5 seconds, because usually it's not a mile away. That's pretty close. Usually it's like 5 or 6 or 10 miles away. You can still see the lightning back over there. So we counted 5 groups of 5s. That would be miles or so. Because 3/5, right? That's about 60%. So a kilometer is about 60% of a mile. So 5 seconds for a mile, 3 seconds for a kilometer. Okay, now, so we could graph this. We could look at the equation. We could look at the table of values. So let's go back to t here. Now this equation, let's take a look at the equation. That can be written like this: 1/3 times t. And then what's the constant? Plus 0. Does this appear to be in y equals mx plus b form? It does. Y, yeah. M, 1/3. X, yeah, that's my input variable. And I do have a constant. So it's in y equals mx plus b form. So yeah, this is linear if it matches the form of a linear function. What about the table of values method? Okay, so this is, we're going up by 1 each time. That's great. What is this going up by? 1/3. Going up by 1/3. Going up by 1/3. So do those seem to match what we're expecting for a linear equation? Yes, they're both going up by the same numbers. So here you would say, yeah, that's linear too. And then if we were to graph it, you would see that the graph would display, we would have points where it's 0, 0 there, and blah, 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 blah. It would be a straight line as well. Okay? So 3 different ways that you could test that. Make sense? Yes? Everybody else? Yeah? Okay. Okay, so that's number 20. Did the whole thing for you, but that's a good one to talk about because you can examine the equation, you could examine the table of values, and you could examine the graph. Now, can I just say one more thing? Because I don't know if we've talked about this much in class, but can I just ask, look at this. What if I didn't test the point number 2, or I used, okay, and instead, so just watch this. What if I did something like this? I did 1, 3, and then I did 4, okay? So just indulge me for a second. Just give me 1 second. Let me see if I can separate this. That's not going to work very well. Okay. So if I did 1, 3, and 4, okay. Why did that not work? So let's say that I picked 1, 3, and 4, okay, and this would be 4/3. Now, notice that this is +2 and +1 and +1. Now, just because I chose these numbers, does it make this now not a linear function? Okay. So you have to, this is a good question because if you see something like this on a test, or if you choose values and you're like, hey, they don't match up like I'm taught. This is +2 here, but notice that this distance here is +2/3. Okay? So is this the same? No. But is this the same? No. So now you have to look closer because, of course, going from 1 to 3 is exactly 2 times going from 3 to 4. You see that? So this still is a linear function, but it would be like we have points. We skip a point, you see? So this is rise over run, yes. This is double the rise has double the run, so we're still linear. Okay? So this is a finer point that some of you need to see and understand. Okay, you all need to understand this, but some of you, maybe this will come up and you'll be like totally thrown off. But just because we have differing numbers here doesn't necessarily mean that it's not linear anymore. Okay, see, +1, ooh, +2, +1, +1/3, +2/3, +1/3. That still matches up perfectly. Okay, does that make sense? All right, that's number 20. Anybody else have any questions right now?